Right. I activate the recording. Right. So the trajectory should be like this, but my question is, what is the velocity at this point? So in this direction there is no force, but in this direction there is a force. That is why we calculate the acceleration. Then the component of velocity at this point is say u, but the component velocity at this point might be here. The vertical component is 0, but here the vertical component might be some value. Let's say it is v, then the separation of the plates is d, then d upon 2 is the distance traveled the particle. Then we can apply v squared equal u squared plus 2as. So the initial velocity in this direction is 0. Then v squared equal to a is eq upon m, s is d upon 2. Then 2 to 2 will be cancelled. Answer is eq d upon m, square root. Then here e q d upon m. So if the total velocity is here, maybe we can find the angle and the component of the total velocity. I will label it as V naught. So V naught is the square root of E Q D upon M plus U squared. The theta is tan inverse E Q D upon mu. So this is the trajectory of the charged particle in a uniform electric field. Okay.
Okay, sir.
So let's do a small calculation. There is a charge having plus Q, and there is a negative charge is equal negative Q. As I told you, this charge emits electric field lines like this, assume Q is very much larger than simple Q. The magnitude of Q is very much larger than simple Q. So this emits the electric field isotropically. So this charge travels in this direction, having the initial velocity u. What will be the trajectory of this charge particle? Directly will it be attracted towards this? And what will be the trajectory? Just think and tell me. I will pour some water to my cup and come back. What will be the trajectory? How soon?
It's a curly path.
Yes. It's a curly path way, like a spiral. And because it can't reach to the plus Q charge particle at once, since it has initial velocity. Otherwise, if there is no initial velocity, yes, it should attract towards the positive charge particle. But if there is a velocity, it moves in a circular path. Oh, I think that is enough regarding that. Curl-free nature of field strength in an electrostatic field. Relationship between the electric field strength and electric potential. Yes, I think I have already given it. We will derive that expression later. We will derive it, but at this moment you better to keep it in your mind. So the electric field is described like this: grad V. V is a scalar. These are vectors. Do you know the meaning of this grad? There are three operations for Cartesian, cylindrical, spherical. There are many operations, but later we will discuss. So for the uniform velocity, uniform field, electric field strength is V upon D. Anyway, from this we can say V equal E D. We can prove it. I will show you how to do it using the Coulomb's equation. We know if there are two charges, the force acting on, suppose this is negative, this is positive. Force acting on those two charged particles are 1 upon 4 pi epsilon naught Q1 Q2 upon R square. This is a force. Suppose this distance, R squared. R is this distance. Maybe let's take it as D. D squared. So if it is somewhere here, what will be the force? Suppose D plus dx delta D. Then force is 1 upon 4 pi epsilon naught Q1 Q2 D plus delta D square. So with this force, the work done, force times the distance is the work done. That's what we need. So what we can do is to find the total potential energy we can integrate this from plus infinity to r, the distance, so d. Let's assume this is the origin, initial position, then infinite to here. So let's take it as it's. This is dx. So the answer is 1 upon 4 pi epsilon naught q1 q2 divided by x squared integrate plus infinity to r dx. So let's do this integration and let me know what is the value. And since it is two, unlike dislike charges, then there is an attraction. Definitely, this work done should be negative. Otherwise, it is positive. Then calculate this value. Do it now. And tell me the answer. Poisson, what is the answer?
Wait, sir.
Manupa?
Yes.
Are you doing it?
So,
Yes.
minus q1 dot q2 divided by 4 5 epsilon naught d.
Very good. Manupa, did you get it?
No, sir.
Not yet. Okay,
Not yet, sir.
I will give you some time. Q1, Q2 also can be taken out because they are constants. The variables are 1 upon x squared dx infinite. The final portion is x. So minus q1, q2, 4 pi epsilon naught What is this? 1 upon x minus. Am I correct? Am I correct?
Yes, sir.
Okay.
Yes.
Infinite x minus q1, q2, 4 pi, epsilon naught. So minus 1 upon x minus 1 upon infinity is 0 actually. Then answer is 1 upon 4 pi epsilon naught q1 q2 divided by x is actually the potential energy. This is the potential energy. So electric field strength is actually 1 upon 4 pi epsilon naught q1 q2 divided by x squared. Don't worry about the magnitude. So when you have a look about these two relationships, you can say E times X equal V. Blindly you can say like that. Then combining these two together, E times X equal to V. Up to now, that is enough.
Excuse me, sir.
Yes.
Sir, when we consider the electric field, so that the equation should be 1 upon 4 pi epsilon naught q within x is q over x square, right?
Yeah.
Yes, sir.
So
There are Q1,
you
Q2.
mean if you consider the unit field, no?
Yes, sir.
Yes, yes. So this is not the electric field. Actually, this is force. For the electric field, it should be 1. Q2 should be 1. Let's assume Q1 is taken from infinite distance to that place. At the origin, no, at the origin, the Q1 charge is there. We bring unit charge from infinite distance. Then here there is an electric field. Here there is a potential. Then relationship between the potential and electric field is this. And in the previous case, force times x equal the potential energy. This is called potential energy. This is called potential. So if we consider potential, that is with the unit charge. So potential energy is the energy taken for the non-unit charge. Shall I wipe the board? Malsha? Malsha?
Yes, sir.
Evening? You are there, no?
Yes, sir.
thought you are doing some other thing. Kevin?
Yes, sir.
You are there. You know why? Definitely in this period, all the ladies are there with the Zoom class because this is time that their mother is cooking. And there is an excuse, they are having the Zoom class, that's why they are coming to the Zoom. Am I correct, Kevin? Kevin,
Sir?
am I correct? Because this time we have to cook now, then there is an excuse. We have Zoom class. Anyway, just I am kidding. I know you are good students. What can we discuss? The Laplace and Poisson equation. Yes. I think you remember the Gauss theorem. Gauss theorem, if there are charges inside this surface, the total flux coming out is the sum of charges divided by epsilon. Similarly, if if we know the surface area, or volume, just for the cube, for the sphere having a radius, what is the volume? Suppose this radius is r. What is the surface area? Four pi r square. What is the volume? First one?
4 by
of the
3
sphere?
pi
Huh?
r cube. 4 by 3 pi r cube.
4 by 3
Pi r cube.
pi r
R cube.
cube. It is a volume. Volume. And total electric field coming out is pi divided by 4 pi r squared. Here, sigma I goes from 1 to n q I divided by 4 pi r squared divided by epsilon naught. This is actually, I don't have a red color. This is actually I'm sorry. The electric field. Electric field. What is this? Maybe here is a charge. How to say? Maybe we can say it's charge density divided by epsilon naught. No, charge per unit area. Yes. Here it is a. I will keep it like this. I have to write it again. So please differentiate this. Please differentiate this with respect to capital R. D E upon D capital R. What is the value? We can take a constant out, sigma q I divided by epsilon naught and 4 pi d upon dr r to the power minus 2. This is what we need. Am I correct? So we have to subtract 1. What is the answer of this, Kasun? Kasun?
Sir, I missed something which was written on the board, sir.
Sorry?
I missed something which was written on the board, sir.
You missed. Did you get this equation? Electric field.
Yes, sir.
So I asked you to do a simple thing to differentiate the electric field with respect to capital R.
Okay, sir.
These days, cream soda with ice is good, but don't take it as a habit, because it contains a lot of sugar. So, are you hungry? Or shall we discuss and stop? Bimsara?
Okay, sir.
Okay means hungry? Or can you manage?
Hungry.
Hungry? Wait. We will finish this. Kazun, what is the answer?
Sir, minus summation of q divided by 2 pi epsilon naught r cube.
Sorry? Summation?
Q divided by 2 pi epsilon naught
No.
r cube.
I mean,
Sir. Minus 2 by r cubes.
minus 2. No, because there is a 2, no. Normally, d upon dx xn is xn minus 1 divided by n minus 1. No?
Yes, sir.
So, similarly, this sigma q divided by 4 pi epsilon naught 1 upon r cube times 3, and the minus also comes. Then it is sigma q I divided by 4 pi r cube, no, 3r cube divided by 4. Therefore, we have to multiply by 1 upon 4. Since we got the 4 here, 3 is there, and 4 r cube is here by r cube. And 1 upon epsilon is here. Again, another 4 is here. Anyway, this is the charge per unit volume. This is called charge density. Charge density. Don't worry about the other parts. What we can get is T upon the R E equal, the charge density is, the notation of the charge density is rho divided by epsilon naught. In 3D case, we can take it as grad E is rho upon epsilon naught. Right? That is derived by the Gaussian theorem. Gauss theorem. Gauss theorem. Now, from the Gauss theorem, and also in the previous case, grad V equal E. Then instead of E, we can, actually this is considered as a Poisson's equation. Poisson's equation. This is a Poisson's equation. So instead of E, we can put grad V, then grad, here divergence of V, yeah, because divergence of grad of V equal rho upon epsilon naught. So so what is that? So when we solve it, we can say this is grad square V equal rho upon epsilon. But this is given an important expression for charge free space. Space. What is rho? Rho is 0. Then for the charge free space, grad square V equals 0. This is called Laplace equation. This is Laplace. This is Poisson's equations. Poisson's Poisson's equation. Poisson's equation. Right. Is there any problem? Marsha? Marsha,
Yes.
is there any problem? Huh? No?
No, sir.
Okay. Pravisha? Pravisha?
No, sir.
No. Pravindu?
Yes, sir.
5835 5839.
Sir,
Oh. What do you mean? What did I ask? 5839. Five eight seven seven. Are you there? Pereira, AMU Pereira.
Yes, sir.
Can you hear me, Pereira?
I can hear you, sir.
Right. I will wind up. Today we discussed about the Curry free nature of the charged particle and Gauss theorem, the extension of the Gauss theorem like the Poisson's equation and the Laplace equation. But we need the good knowledge of the calculus, especially to handle it with the three-dimensional case. The Cartesian and the spherical coordinates are enough. We need some good knowledge to discuss further, but don't worry, there are many mathematical tools to solve that. They simplify it. And today I will wind up. Can we get an extra class? Kasul,
Yes, sir. Yes, sir.
can we get an extra class?
Yes, sir.
When? Kasul, please coordinate with your colleagues and let me know if there is a free slot. Maybe at night, I'm okay. And also, I need help from you. Wait for a while. Since the webcam is not good, I reviewed in the YouTube, and the people say Logitech webcam is somewhat okay, but I came to know the DSLR cam gives a very good performance rather than the other cams. But to operate this, we need to have a video capture card. Video capture card. Can you, if you know any place, please let me know where to buy the video capture card. I think these days Unity Plaza is also closed, no? Am I correct, Pasun?
Sir, you can, if that has a HDMI output, sir, you can send it to the laptop and record using OBS.
OBS means?
It is a software, sir. It's a free software where you can connect devices like cameras. You can use your Android phone.
Manupa, we can't use it for the Zoom, no?
We can, sir. If you are using Windows, sir, you can turn on the virtual camera on OBS, and then from Zoom, you can select the default camera as OBS.
Oh, I didn't come to know about that, but I think I have the. Yes. It is not HDMI. It is you want to take the images of the cam. This is not HDMI. I don't have the HDMI.
If there is a way to take video out, sir, even using the USB or Wi-Fi, then you can do that. Or even an Android phone, sir, you can use to do that. There's an app called DroidCam.
But Android is also, first we have to find the HDMI cable, no?
Sir, there's a app called DroidCam. That in that you can use Wi-Fi to send the video.
Wi-Fi to send, but here there is no Wi-Fi. That is another problem. But I don't use this. That's why I can make use this for the online classes. And let me know if we can find the accessories in this period. And I can directly go to that place and buy it in Colombo and suburb. If you know, please let me know. Maybe HDMI cable or Manupa, where are you from?
I'm from Colombo, sir.
Colombo. Let me know if the shops are open in these days. I think the Unity Plaza is closed, no?
Most of the shops are closed, sir, but I think by contacting them, we can buy stuff like contacting the
seller. And let me know if you have any contacts, and the other student also can support me. And if I can find the correct accessories for this, there is no problem, then you can read the board clearly. I have the tripod antenna and everything. I can fix it and give the good service for you, right? So I will wind up. You can contact me. I will type my phone number. Yes. Let me know if you get any place to solve this problem. Okay, goodbye. Bye.